computer, share screen, desktop 2, and let's do it. So, Allie, can you tell everybody what you found and how you found it?
Well, I bought it at the store and I saw it was expensive, but that's okay. My mom bought it 3 of them, but that's because we wanted some chocolate milk, so we got it, and then we found it, so it's 3 inches.
So it's 3 inches was the diameter.
No, it's the ratio.
It's the ratio.
Oh, the ratio. So it was a 3-to-1 ratio, diameter to the height, and that would make it.
Oh, yeah. Okay, so
Yeah. So Allie, I'm so excited. You know, I don't know if anybody saw this, but I sent around a picture of a paper towel roll during the week. And that picture was not the perfect cylinder. It was twice the perfect cylinder. So it was twice as tall as it was round. So I consider that double perfect cylinder. So are you guys ready for the big challenge this week? Now,
Yes.
I asked your parents, I said, hey, do these guys maybe have some matchsticks or some toothpicks? So I have all of these matchsticks, okay? And I use them to create puzzles. You guys see the puzzle that I'm showing you right now?
Yeah.
Okay, so what I'm gonna do is you should be able to see my puzzle right now. Now, in order to understand my puzzle, what you guys need to do is to know a little bit about Roman numerals, okay? Roman numerals. So what I'm gonna do, and you guys don't have to create this if you don't want to. You can just sort of watch what I'm doing. So I'm showing you now, I basically made this group of matchsticks to create a number. So what number do you think you see right over here? There's a few different answers that you could give me. What number would you say that represents right there? Tess?
11.
Okay, does anybody else know another number that could represent? Charlotte?
2.
Yeah. So what's really interesting, guys, is that this right here could represent the number 11, which of course you know is 10 plus 1, or it could represent the number 2. Now, who knows in what number system would this represent the number 2? Because usually we don't write a 2 like that, do we? So who thinks they have an idea? And Allie, do you have an idea about that?
Roman numerals.
Everybody say it out loud. Roman numerals. Roman numerals. Now, Roman numerals are very, very exciting to me. I will tell you why I love Roman numerals. I love Roman numerals because it's actually from ancient Rome. And a lot of people think, and listen to this, a lot of people think that the reason that Rome, ancient Rome, fell as a superpower is because they used Roman numerals instead of Arabic numerals. So the Arabic numerals, everyone, Those are the ones that you know as 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are called Arabic numerals. And Roman numerals look like this. I, 2I, 3I. Who can tell me what 4 looks like in Roman numerals? Does anybody know what 4 looks like with Romans? And if you could raise your hand electronically, I would definitely love to see it. William, we're going to start with you, buddy.
It is a V.
You said it is the, can you say it again, please?
It is V.
Oh, V. Yes, yes, yes. That is correct for the number 5. That is correct for the number 5. Charlotte, can you help me out with the number 4? Because it's a little bit different than the number 5. So William, that was a great start. Charlotte?
So you make 4 I's and then put the 4 I's together.
Now guess what? I'm gonna say yes and no. Can you believe it? A math teacher saying yes and no. So when they write 4 I's, I have seen people do that before. But that is not the standard way that the Romans did it. Victoria, do you have an idea as well?
I was going to say 4 I's.
You were. And Allie, do you have something different, love?
You almost got it.
A Y and a V.
Oh, an I and a V. Xander, were you going to say that too, buddy?
Yep.
All right. Now, guys, look at this. Do you know that this is subtraction? It really represents 5 minus 1, which is the 4, whereas the V, William, represents the 5. And then who knows how to make a 6? Somebody else raised their hand. Doris, what do you think? Valerie, Alice, what do you think? Sabrina, what do you think? How would we make a 6? If 5 is V, how would the Romans have made a 6? Raymond, go for it.
Mommy?
Oh, Raymond, you are muted, so you got to unmute yourself. Try to keep yourself unmuted. Go for it. Go for it, Raymond.
A V on the left and a 1 on the right.
Oh, man. I got to tell you, Raymond, not only am I excited about the answer, but I'm excited about the way you gave your answer. Guys, do you understand how Raymond is speaking like a mathematician? He said V on the left, I on the right, and that is 6. Now, everybody on 3, give me the number 7. On 3. 1, 2, 3. V-I-I. And what about the number 8? The number 8. Are you ready? On 3. 1, 2, 3, go. I. So Now, everybody stop right now and think. Remember, we're not allowed to do 4 I's in a row. So when it comes to the number 9, there's a little bit of a difference. We're going to be using subtraction again. So I want you guys to raise your hand right now. I closed everybody's hand. Raise your hand right now if you have an idea for the number 9. And Tess, I'm going to choose you first. X. Now, I want to tell you something right now, everybody. Do you know that Mr. Kramer has the iPhone X? Now, the iPhone X came after the iPhone 9, and it came before the iPhone 11. So what do you think, Tess, that X represents?
10.
That's right. Now, everybody on 3, oh, wait a minute, hold on a second. Alice, can you tell me what 9 would be?
3.
Say again, love.
3.
Well, V is 5. And so I'm looking for a 9 right now. Xander, do you have it?
1x.
Oh my gosh. Did you just use subtraction again, Xander?
Yes.
Did you do 10 minus 1 to get 9? Not only that, but Xander's name starts with an X. How cool is that? Okay? And in fact, I think maybe we should call Xander the 10 man.
How is this a
10 man. Now, I'm wondering if everyone, Doris, you have a question, buddy? Okay, your hand is up. Do you have an answer? No? Okay, that's no problem. Keep yourself unmuted so when I ask you a question, you can answer it. Allie, you have your hand up.
My mommy has an iPhone X.
There we go. Do you know that the biggest, most powerful company in the world still uses Roman numerals? Oh my gosh. Yes, the iPhone X is iPhone 10. And Charlotte?
So, the I and X I just made.
Oh, look at that. That's beautiful. That's beautiful. Now, everybody, the iPhone 11, which unfortunately is called the 11, what would it be called in Roman numerals? Who knows? Victoria? And how about you, Sabrina?
See? Wait, let me see. Please.
How about the number 11, Sabrina? Go ahead.
2.
The number 11. The number 11. What do you think? If X is 10 and I is 1, what do you think we do to put 10 and 1 together to make 11?
XI.
Oh my gosh, Sabrina, you totally rock. And then what about number 2? Wait, the iPhone 12, when it comes out, what could it be called?
Here's the book.
X what?
I.
Aye, Gabby, aye. Gabby, you sound like a pirate. You sound like a pirate. Okay, are you guys ready? Here's the big challenge. The big challenge is, what can you guys do to solve this puzzle? Your job is to move exactly 1 matchstick to make this equation work. By the way, you're not allowed to do anything with the equal sign. So this is so difficult. Can anybody tell me what this number is right here? What number in Roman numerals is XXIII?
23.
Raise your hand electronically. On 3. 1, 2, 3, go.
23.
And what about the number on the bottom? Don't say it out loud yet. Let everybody think about it. On 3. 1, 2, 3, go.
11. 11.
Well, hold on a second.
7.
This one is a V and an II. Do you remember what William told us? That V was the number 5,
7.
and 2 is the II. So if we look at VII, what do we get, everybody?
7.
That is correct. So here's what we're gonna do. Mr. Kramer is gonna erase that, and I'm gonna put a 7. Now, 23 divided by 7, does that equal 2?
No. No.
Absolutely not. Who can tell me what would equal 2? If I divided a number by 7, what would that number have to be for it to be 2? Now, division is just the opposite of multiplication, and multiplication is just repeated addition. So if I count by 2, 7 times, or if I count by 7 2 times, on 3, everybody say it. 1, 2, 3, go.
14. 14.
Now, is there any way that I could move one matchstick on the top and make it a 14? Because if I can do that, we have our answer. And guys, you know what I tried to do? I tried to move this guy to kind of look like a V, and XV is 15, but that didn't really work out because I needed a 14. Now somebody, Charlotte, you just raised your hand. What do you think?
I'm confused.
Well, you know that 14, do you agree, Charlotte, that 14 divided by 7 equals 2? Do you agree with that? That 14 cut into 7 equal pieces equal 2, because 7 is half of 14. Does that make sense, Charlotte?
Yes.
Now, Charlotte, if I can make this number up here be 14, then I solved my puzzle. But I'm having trouble with that. Victoria, do you have any ideas?
So can you make 5 and then make a -1?
You could do that if you could somehow, so watch this. If I could move this matchstick, guys,
No, I didn't.
and I could make it kind of look like a V. Do you guys see it?
Mm-hmm.
And then I somehow could remove these two. Wouldn't that be 14?
Mm-hmm.
Because I would have X, I, V. IV is 4, X is 10, 10 plus 4 is 14. But am I allowed to move more than one matchstick?
No, no, no.
No, no, no. Now, you're not going to believe this, guys, but I was thinking of another solution. Would you like to see my other solution I was thinking about? I was also thinking, what if I took something to make this a 3? What if I moved what if I moved this over here? Tell me what equation I'm looking at right now. What is the number XXII?
22 divided by 5 equals...
No, not 5. 22 divided by what then?
7
Equals what?
equals 3.
Whoa. Guys, is that a true equation? How many times does 7 go into 22? Who would like to count with me? I'm going to ask you guys
3.
to count with me. We're going to count by 7s on 3. 1, 2, 3, go. 7.
7, 14, 21.
Wait a minute. Stop right there. If we are saying 22 divided by 7, isn't this going to be a little more than 3? Because isn't 21/7 equal to 3?
Yeah.
Uh-oh, wait a minute. Allie, what are you thinking?
Yes.
Yes, and Victoria, what are you thinking, love? And also Xander, if you have something to add.
Can you go to the last page where we were from the matchsticks?
Yes, I'll go right there. Victoria, do you have anything you want to add to that?
I just forgot to put down my hand.
Okay. Now here we are, Xander. And Victoria, you put your hand up again, Victoria. It's okay. Yeah, be careful not to hit that button if you can. Now, Xander, look at this. We know that 22 divided by 7 does not equal 3. Because
If you basically move the second X's and turned 2 of them to make 4,
how would I turn them?
like you turn them into straight,
Oh, so I would basically turn.
like from here to here.
So like this, wait, hold on. Like this and like this.
Yes.
Now you have 14 divided by 7 equals 3.
No.
And that is not true because 14 divided by 7 equals 2. So Xander, that was brilliant. But guys, do you see what just happened? Do you remember, guys, last week what the whole lesson was about? What was our whole lesson about last week? Wasn't our whole lesson last week about the number we call pi? You remember that?
Yeah.
And do you remember that pi equals about 22/7 over 3 and a little more? Remember? 3 and a little more? Well, guess what? Watch this, guys. Mr. Kramer is going to take away 1 matchstick from the 23, and I'm going to make a what out of the 2?
A pie.
Everybody look at it. 22/7 equals pi. And it's not exactly equal to pi. It's approximately, but I didn't want to bend the matchstick. So we're going to say that it equals pi. Now, this kind of math can be a lot of fun. I want you guys to look at this one right here. 5 plus 7 equals 2.
No.
We know that 5 plus 7 does not equal 2. So everybody give me a big thumbs down. But what can we do? Can we move exactly one matchstick to make this equation work. And by the way, there are 2 ways to make it work. Now remember, you can move any matchstick. I can move this one. I can move this one. I can even move the matchsticks on the plus and minus signs. Allie, what do you, or Gabby first. Gabby and then Allie, what do you think?
If you take away the up and down one on the plus sign, you have minus, and 5. Oh, that would only. Oh yeah, because 2 equals 7 minus 5.
Oh, guess what, everybody? Everybody look at what Gabby just did. Gabby, that is amazing. 5 take away 7. It's not exactly 2. It's something called -2. Now,
And we can put that matchstick in front of there to make it -2.
well, guess what, everybody? Guess what? Gabby just found a solution that Mr. Kramer did not find. Everybody give Gabby a round of applause. That is amazing. Everybody unmute themselves. I think Gabby really rocks. Now, Gabby, here's what I'm gonna have to do. I'm gonna now go to my other page, and I wanna ask anybody, do you think there's something we can do without making this a -2? If we take away the plus part from the and make it a minus sign, can anybody tell me what we might want this number to be? Allie, do you have that idea? What could this number be here, -7 to equal 2? Raise your hand electronically if you have an idea. Do not say it out loud. Isabella, I want you thinking about this. Valerie, I want you thinking about this. Very, very important. Okay. I've got Allie. Do you have it, Allie?
9.
Oh my gosh. Everybody give her a round of applause. Awesome.
Yeah.
Now, guess what? There's one more solution that I found. And whoops, that wasn't it. There is one more solution. Now, this solution does not include getting rid of the plus sign. Raymond, what do you think?
Troubleshooting everything. Troubleshooting.
Move the
No, I mean
matchstick
for the
on the bottom of the 7 and move it to the 2.
Wait, hold on. Somebody, there's background noise on someone's end. If you can mute yourself, that'd be great, because I hear somebody talking to someone else. Okay, Raymond, go for it.
Move the matchstick on the bottom and move it to the 12.
Wait a minute. Do you mean this one right here, Raymond?
Yeah.
Oh my God. Guess what, guys?
Not really. I mean,
Wait, guys, does anybody have a parent talking in the background where they are? Raise your hand if you do. Raise your hand if you hear a parent talking in the background, because nobody's gonna raise their hand? Okay, bummer. Okay, so Raymond, that was absolutely brilliant. Everybody look at 5 plus 7. Is 5 plus 7 equal to 12, everybody? Is it? Please
Yes.
give Raymond a big round of applause on that one. Now, guys, Mr. Kramer loves to create his own puzzles. I love to create my own puzzles. And so what I want to teach you is how to create your own puzzle. So everybody look at the equation that I'm showing on this page. Now, do you guys agree that 5 plus 2 equals 7?
Yes.
Now, when you create your own puzzle, I create an equation that actually works. I start with a correct equation, and then guess what I do? I move one stick to make it false. Are you ready? Watch this. Uh-oh.
9 minus 2.
Did that work?
9
No, that made it true also. Huh. So that didn't really work. So what I'm gonna do, watch this, everybody. Look how I moved. What did I just make that?
plus 2. 3 plus 2.
And you know that 3 plus 2 does not equal 7.
Plus 2 equals 5.
So this is a great way for you to create your own puzzle. So you could give that puzzle to your parents and say, Mom and Dad, move one matchstick and make this equation correct. And then they would simply move that over and make the 3 a 5. And they would say, is that it? Is that it? Charlotte, what were you gonna say? Charlotte, you are muted. That Gabby's muted, Isabella's muted.
I think I figured out how to do the 6 plus 4 equals 4 one.
Oh, well, you know what? Let's go down there and let's take a look at that one right now. So the one that we're looking at right now, I want everybody looking at 6 plus 4 equals 4. Now, there are exactly 3 different solutions. So what we're gonna do is we're gonna take, now, is it Charlotte that you have the solution or is it Gabby?
I have the solution.
Charlotte, okay. So Charlotte, you're gonna give us your solution, then I'm gonna teach you something else, and then we're gonna find the other 2 solutions. Are you guys ready? Go for it, Charlotte.
So instead of the plus sign, you have to make it minus, and then you use the stick, and then move it to the 6 to make an 8.
Guys, does Charlotte rock or what? Come on, give her a round of applause. That is awesome. So creative. I can't believe it. I can't believe it. Now, are you guys ready for the thing I'm gonna teach you now? I'm gonna teach you how to transform letters. I'm gonna teach you how to transform letters. So, I'm sorry, numbers. So if you use matchstick numbers, everybody look at the number 1. What could you do to the matchsticks? You can either move one matchstick or you can add a matchstick to it. What could you do with the number 1? And I want you thinking about this. For instance, you would say, oh, Mr. Kramer, we can convert the number 1 to a different number. And I actually think there are 2 choices. There are 2 choices here. So I want you guys thinking about it. And if it were me, this is what I would do. I would take the number 1 and put it on in front of where I'm sitting right now. And I would look and I would say, how can I move these around or add one more to make it the number that I want? So I'm gonna start with you, Alice.
7.
Oh my gosh. Do you guys agree that the number 1 can become a 7? And how can it become a 7, Alice?
Add on one more stick.
Okay, everybody watch it. Now watch this. There are 2 ways to do it. I can add on a horizontal stick, yes, to the top.
Yeah.
Does anybody see another way that I could make a 7? What if I took this stick from the bottom of the 1 and I turned it around? Could I then make that into a 7?
Yes.
Wow, that was really, really cool. So Alice, I totally agree. Does somebody else have another solution? 1 can become a what? And this is a little difficult to think about. Tess, do you have that one, or yours was the 7?
Mine was the 7.
And Allie, what is yours?
Mine is if you take a 1 and then you flip around the 12, you can make a 13.
When you say, if you take, explain.
Like if you flip around the 12 and the 3, you make and then you put them in the other spot, you can make a 13.
Now, that's true. If I took all of these away, yes, you could have a 13, okay? But what we're doing is we're only moving, and that, Allie, that was brilliant. We are only moving 1.
Okay, I have it. So if you add if you add a dot right there, it could be like something. Actually, if you add like a bottom, if you add like 3, you could make an 8 by pitting a top and then pitting a bottom and then crossing it.
Yeah, so Allie, there's a lot of different ways, but we're only looking at the number 1 right now. And I'm gonna hold that thought on the 8 for just a minute. And Raymond, what did you think? Raymond, what did you?
You can take the 1 on the bottom and put it side by side on the 1 on the bottom, on the top.
And make it a what?
11.
Ah, everybody look at that. 1 can become an 11. Now, I also think that 1 can become a 1. Isn't that funny? You could take one of the matchsticks away and it's still a 1. So I'm going to write down Raymond's, and then I'm going to write down 1 can equal 1. Victoria, did you have another one?
Well, mine was you take the bottom matchstick and put it on and put it right where the 2 is when it's going left.
And make it a what?
And make the 2 a 9.
Ah. Now, does that make a 9, or is that
That's
a
crazy.
backwards 9? I love it.
It's 9.
I love it. What do you think, Victoria?
Backwards 9.
Yeah, but man, Victoria, you know that I'm loving that one. Now, everybody go to the number 2. Come on, guys. What could the number 2 become? And I only have one solution for that. Who thinks they know what 2 can become? Gabby?
6 by putting an extra matchstick, well, at the bottom space.
Oh, hold on. Like right there?
Backwards, actually. It's backwards.
Yeah. You know, I have to say, Gabby, the only way to test these is to try it out. So you guys need to take the matchsticks or the toothpicks and create the letters on your own. That was beautiful. Now, I'm going to ask you again, does anybody have another idea? Tess?
3.
Oh my gosh. Everybody look at it. And Tess, tell me how to do it.
Take the one on the left and move it to the right.
So remember how Raymond was very, very specific? You take the one on the left, but you have to say the vertical one on the left and move it to the right. Did we just make a 3 out of the number 2, guys?
Yes.
Oh my God. Now, wait a minute. If we can make a 3 out of the number 2, what could we do with the number 3? Oh my God. By doing the same thing? Wow. That is really, really cool. Wait a minute. Guess what, guys? I found 2 other things that we can do with the number 3. Don't say it out loud, but raise your hand. I'm going to put everybody's hand down right now. Raise your hand electronically if you can tell me what else we can do with the number 3. Because this is going to help us make our own puzzles. Jeremy, I want you to really give me this one. Isabella, I want you to start your video so I can see that you're working it. Now, Valerie, what I see Valerie's desk. And so what I would like to see is you guys make the number 3. Let's see, how do we make the number 3? If we make the number 3 like this, and so if you start with the number 3, and of course you know you could make the number 2, but I want you thinking what else you can do. So your job is to really work these numbers. And oh, I see, oh, look at that. I see Isabella working her numbers. William, are you working your numbers, buddy?
But there's one problem.
You don't have any matchsticks. So,
Yeah.
William, use toothpicks, use pencils, use anything that is straight, or just draw it with a piece of paper. Draw it with your pencil, and then you can erase the one piece.
All right, I have a whiteboard right over here.
Oh man, William, a whiteboard is the best. Whiteboards are the best. So, Xander, I'm going to start with you, and then Gabby. Go. Go ahead, Xander.
If I know 2 other ways.
Give me one of the 2, and then I'll go for Gabby for the other one.
Use the 9 and take out the matchstick from the 9 that's blocking.
You
So
mean,
right,
what do you want to turn 3 into?
like I'm gonna use 9 to make 3.
Yeah, but I want you to make 3 into 9. How would you make a 3 into the number 9?
Oh, use the plus and put it in the front.
Oh my God, guess what? Xander nails it. 3 becomes a 9. Awesome. Okay, now, Gabby, what's the next one we could do? 3 can also become a what?
A 5. Because if you can turn 3 into a 2, you can turn 3 into a 5.
Wait a minute. Gabby, do we move the vertical line on top to the left side?
Yes.
Everybody, is that crazy? Oh, William, you're the man. I love it. So guys, everybody can write that down right now. And guess what? If 3 can become a 9, then we know that 9 can become a what?
A 3.
If 3 can become a 5, then we know that 9
5
can become
can
a
be
5. Awesome. Now, what about the 4? Oh my gosh, you wouldn't believe this, guys. Mr. Kramer found 4 different solutions for the number 4. Now, 2 of them are a little crazy, but 2 of them are not so crazy. So I want you guys thinking about what you could do with the number 4. And I'm going to start with you, Alice.
4 can be.
Alice, do you have an idea about that? Or do you want to still think about it? Alice, are you there?
Yes.
How about you, Valerie? Are you trying to make something out of the number 4 into a different number? What could you do? What could you do? And let's see. Let's try Raymond. Go, Raymond. Oh, wait, I'm sorry. Jeremy, do yours first and then Raymond. Go for it. Oh, Jeremy.
You could add a line at the top of this board.
Oh, buddy, I cannot hear you. I think you're going to have to give some volume to your voice. Jeremy, try it one more time. 4 becomes a what? Just give me the number.
A 9.
A 9. A 9. How is it possible to make the 4 into a 9? Just give me the method.
Or you're just missing one piece, which then it could also be a 9.
Yeah, but where's the piece? Tell me, is the piece horizontal? Is it vertical? Horizontal, vertical. Which one? Louder, please.
Horizontal.
Very nice. Does everybody see how the 4 becomes a 9? Okay, Raymond, what do you have for us?
Move the one on the right and the horizontal one on the bottom. Move the horizontal one on the bottom and put it on the top and make it vertical.
But what number are you making the number for?
0.
Oh, whoa. Everybody look at Raymond. Raymond, I love it. Everybody watch this. Take that vertical, make it horizontal, and guess what? He just turned a 4 into a 0. That was awesome. Gabby, do you have another one? Gabby, you're muted. Go for it, Gabby.
I forgot to lower my hand.
No worries. Okay, guys, guess what? I've got 2 more for you. Are you ready? Here are the crazy ones. We're going to make the 4 into an 11. Watch this.
1.
Take out the horizontal, make it vertical, and did we make a proper 11 out of 4?
Yes.
Pretty cool. Now, the next one that I did, I'm not so sure that I'm really allowed to do this, but I thought I would have some fun with it. And I'm not going to write the number down just yet. I'm going to first show it to you. Are you ready? Take the horizontal. And what do you think I just made?
71.
Guys, do you see the number 71?
Yeah.
Is that a little silly?
Yeah.
All right. So now what I want to show you, I want you guys to try to finish this chart. find all the ways to make a 5, a 6, a 7, an 8, and a 9 transform into something else. Make the plus sign transform into something else. Make the minus sign transform into something else. Now, watch this. I gave you so many puzzles. And are you ready for my next favorite one? My next favorite puzzle is this one right here.
This one is a little silly.
It is a little silly. Mr. Kramer didn't really, I just thought it was a little silly. And mathematicians can be silly sometimes.
Little silly.
I'm only allowed to move one matchstick, and I want to make 4 triangles.
Oh my God. How do you do that?
Now, I start with 6 matchsticks, and you're going to laugh at me when I show you the answer. I guarantee you. I know you laugh at me anyway, so what's the difference? Would you guys like to see it? It's
I want
crazy.
to see the silly answer.
It's crazy. Are you ready? Take that matchstick, make it vertical, and what do we have? Do we have 4 triangles?
Yeah.
Now, did I tell you were gonna laugh? Okay, this is definitely one of those funny ones. Now,
Try.
would you guys like to see one of my favorite ones? This one here. Can you make 5? You have to move exactly 5 matchsticks from these 11 to make the number 9. And I want you guys to have some fun with this one. And do you know, I just want to tell you that I have 2 students, and guess what their last name is? Do you want to see what their last name is?
Yeah.
Their last name is 9. So can you think of how I did this? I'm going to give you a little hint. You ready?
Oh. 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 N-I-N-E. Made it now. N-I-N-E.
And then what do I have to do
N-I-N-E.
with these guys?
Next 3.
3, 4.
And what should I make out of these 3?
E. 5.
Did we just make the 11 matchsticks into the number 9 by moving 5 of them? Okay. And this was inspired by one of my students who has a last name of 9. Now guys, we don't have much time. So I just want to show you some of the other puzzles. You're going to move exactly 2 matchsticks, and you're going to have the same shape, but the quarter or the coin is going to be outside the shape instead of inside the shape. That one I love. This one is one of my favorites. You have to move exactly 3 matchsticks, and you'll have exactly 3 identical triangles. Now, if you're able to do this, you can be entertained all summer long. And I want you to have a lot of fun. And remember, it's all started with pi. It all started with me thinking about the number pi and how we could be creative in remembering that the number pi is 3 1/7, or just think about it as 3 and a little more. Guys, it has been amazing to see you this week. Next week, I will be with you, but I'll be away on a boat somewhere. So maybe you'll get to see some boats in the harbor in the background. And I'm thinking of a lesson right now that I think you're really gonna love. Okay, guys, everybody say goodbye to your buddies.
Bye.
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 Bye, Jeremy. Bye, Sabrina. Bye, Doris. Bye, Charlotte. Bye, Raymond. Bye, Tess. Bye, Zach.
Bye.
Bye, Victoria. Bye, Gabby. Bye, Alice. Bye, Valerie.
Bye, everyone.
So good to see you. Love you guys. See ya.